This video will cover the topic graphing an exponential function f of x equals a times b to the x. A classic function of this topic is f of x equals b to the x, where b is greater than 0 and not equal to 1. This is one number raised to the exponent of x. In this video, we will explore a function of the same kind with a coefficient in front of it. Let's say that we have the function f of x equals negative 2 times 5 over 4 to the x power. In the problem, we are instructed to graph the function by drawing the asymptotes and plotting the points at x equals negative 2, negative 1, 0, 1, and 2.
How do I figure out the asymptotes in this kind of equation?
In a function f of x equals a times b to the x, there is always a horizontal asymptote at y equals 0, because this kind of function is either always above the x-axis or always below it. To prove this in numbers, we will think of negative 2 times 5 over 4 to the x for very small x. As x approaches negative infinity, f gets closer and closer to 0, which is a horizontal asymptote at y equals 0. Here are some other things to look at before graphing this kind of function. If a is positive, then the whole graph is above the x-axis. But if a is negative, then the graph is reflected over the x-axis, making it so that the whole graph is under the x-axis. If b is greater than 1, then the graph increases. But if 0 is less than b, which is less than 1, so b is a fraction less than 1, then the graph is a decreasing function. Note that these are true when the graph is above the x-axis, but this information must be flipped when the graph is below the x-axis. From this information, what should our graph at least look like?
Well, we already know that there's a horizontal asymptote at y is equal to 0. And then because the coefficient is negative, that means that the graph is under the x-axis. Then, because b is greater than 1, that means that the function increases. So it actually looks like an upward slope. Oh wait, the graph is below the x-axis, so it's actually a decreasing function. So it looks like a downward slope, because it is reflected over the x-axis.
Very good. We will now see this and get our exact graph by plotting the points x equals negative 2, negative 1, 0, 1, and 2. Let's make a table. Here's our table with our x values on the left, negative 2, negative 1, 0, 1, and 2. And on the right, our value for f after we plug in x in the equation. So let's start with our first value. Negative 2 times 5 over 4 to the negative 2 equals negative 32 over 25. Because 5 over 4 to the negative 2 equals 16 over 25. We multiply that by 2, we get negative 32 over 25. Negative 2 times 5 over 4 to the negative 1 equals negative 8 over 5. Because 5 over 4 to the negative 1 equals 4 over 5. We multiply that by negative 2, we get negative 8 over 5. Negative 2 times 5 over 4 to the 0 power equals negative 2. Because 5 over 4 to the 0 is 1, times negative 2 equals negative 2. We have negative 2 times 5 over 4 to the first power equals negative 10 over 4, which is simplified to negative 5 over 2. Then we have negative 2 times 5 over 4 to the second power, which equals negative 50 over 16, because 5 over 4 squared equals 25 over 16 times negative 2. It was negative 50 over 16, which is simplified to negative 25 over 8. We will now plot these points on the graph, draw the horizontal asymptote at y equals 0, then click the graph button to get the final graph. We'll do this on the Alex graph. We'll start by drawing our horizontal asymptote at y equals 0. So we click on our asymptote button and click on y equals 0. We'll then plot our point negative 2, negative 32 over 25. The best way to do this is to click the plot a point anywhere button. We'll type -2, comma, -32 over 25, and plot the point. Then we will plot -1 at -8 over 5. Then we plot 0, -2 and then we plot 1 at -5 over 2, and then 2 at -25 over 8. Now that we have these 5 points and the horizontal asymptote, we can click on our graph button, and we should get our final drawn graph.
Oh, so it's a simple matter of plotting the points. But to recognize what the graph looks like, I can figure it all out by looking at the sign of the coefficient and whether the base number is greater than 0 and less than 1, or greater than 1. This is very useful. Thanks.
You understand that very well.